Hello everyone, welcome back to another class on regeneration biology. And in today's topic, as you can see here, it is about ethics and ethics of stem cell research in regeneration studies and regenerative medicine and biotechnology. So this topic may sound little dry with no too much of pictorial details, etc. But as and when we go to each topic contents, you will understand how important is to take care of or bother about the ethics. Let us think about what are the ethical aspects of stem cell research. Recent findings in stem cell research and biotechnology, particularly concerning sources beyond embryonic stem cells, are reshaping the ethical landscape, moving towards a more nuanced understanding of natural stem cell therapies. For example, beyond embryonic stem cell, what are the angles we should proceed or we should think about? Traditional ethical concerns primarily focused on embryonic stem cells due to their potential for creating human life and the moral implications of destroying embryos for research and their applications. So this is the primary ethical concern, in the sense, if embryonic stem cell research is promoted, people will keep making embryos or they abort embryos, human embryos, and it will be like a business. So this is one ethical concern. So you have no right to kill a human embryo. That is one angle. But then alternate sources have come. What are they? Research have identified stem cells in various other sources like adult tissues such as bone marrow, blood, amniotic fluid, umbilical cord blood, as well as the techniques to reprogram adult cells, that is induced pluripotency cells, etc. have come into picture. So now the so-called embryonic stem cell, that angle, that the so-called ethical angle is kind of diluted, and then certain other angle have come forward, that is natural stem cell therapy. The concept of natural stem cell therapy arises from the observation that the body naturally utilizes stem cells for repair and regeneration, particularly in rapidly dividing tissues like blood cells. Now the question is, situations we will discuss. So one angle is you are using stem cell from some source, say known source, unknown source, or the patient derived source, and you are manipulating it and putting into the patient is getting benefited. That is one angle of stem cell therapy. Then one can ask, so you unnecessarily made an unfit person fit and allowed him to survive another, gave him chance. So this is against natural selection. This is one ethical angle. Second thing is, stem cells should be used only for research purpose, not for changing the life landscape of a person. So these are another ethical angle. When it comes to the natural stem cell therapy, without intervention of a clinician or a doctor or anyone else, the naturally occurring stem cell, not adult stem cell, naturally occurring stem cells originated from some other source. We will discuss about that, and that contributed, but that stem cell doesn't belong to that patient. Then how does this come into picture? So those are the angles we have to discuss. So if you look further, the ethical consideration with alternative sources, examples of alternate source of stem cell, alternate means alternate to embryonic stem cell, somatic stem cell. Ethical debates surrounding the collection and use of somatic stem cells from aborted fetuses and umbilical cord are emerging. So aborted fetus, and one can ask, if a fetus is aborted due to some reason, how can the stem cell from that fetus is useful? This is another question. But the fetus may have aborted not because something wrong with the fetus, but something wrong with the mother. That is also we have to think about it. So in some angle fetus may be bad, in another angle fetus may be good, mother is not good. So nothing technically wrong in collecting an aborted fetus, but it can become a business. This is the angle you should explore. Induced pluripotent stem cell, iPSCs, using iPSCs, which are adult derived cells, they are reprogrammed to act like embryonic stem cell, raises questions about the potential for off-target effect and long-term safety for using altered adult cells, because you're taking the cells, altering it, and once they become stem cell, how sure we are that the methodology used for altering it is completely disappeared. It may still have that relics, that epigenetic changes or whatever transcription factor that are expressed as a part of alteration may linger around, and that can create a chance of getting cancerous. That's also possible. And perinatal stem cell. So in this way, the ethical angle is, you were trying to help a patient. In that process, you gave him a death sentence through cancer. This is the angle which you should. If you haven't intervened, probably he would have lived another few more years peacefully with that organ defective. But now you tried fixing it through stem cell, and he ended up getting cancer, he or she. Okay. So perinatal stem cells found in amniotic fluid and umbilical cord blood cells are also being explored extensively, but their use raises questions about the consent, storage, potential future applications, etc. They are very unclear or a gray areas of research. Let us think about an overview about ethical concerns. The biotechnology and stem cell research, if you look closely, biotechnology is crucial in developing tools and therapeutics by modifying and engineering stem cell. That is the soul of biotechnology. That is, you are able to intervene and interfere with the natural situation which suits your convenience. Like, if you think about it, milk you make into paneer or a cottage cheese, and cottage cheese you use for making a dish. Something, this kind of transition you should think about it when you are saying about how biotechnology tweaks a given cell. Ethical frameworks, when you look closely, a stem cell research progresses applying existing ethical frameworks and considering new ethical implications is crucial, especially regarding the clinical translation of basic stem cell knowledge into safe, effective and acceptable patient therapies. So this is one of the major implication one should keep in mind, that the ethical frameworks should not be broken under any circumstances. Let us give some examples of the stem cell therapy. Hematopoietic stem cell transplantation, which is extensively done these days. This is the only FDA approved stem cell therapy used to treat blood cancers and other conditions which can be fixed through bone marrow transplantation. That is an approved strategy. It can be from the relatives or tissue matched controls, because it is a less complex tissue in the body. Maybe if it is an unrelated individual, you may have to be under immunosuppressants rest of your life, but still it is an approved therapy. And stem cell therapies for other diseases include, research is underway to develop stem cell treatments for neurodegenerative diseases, diabetes, heart disease and other conditions. They are also underway because stem cells can hold the key to fix this trouble. Let us think about the ethical challenges. What are the ethical challenges comes through this? Informed consent, that is ensuring the patients understands the risk and benefits of stem cell therapies is crucial. And it's not easy. You cannot tell a patient that we are fixing you, but you may end up getting cancer. No one is going to tell that, okay, I don't mind getting cancer, I want this disease to be fixed. Nobody will say. So this is one angle one has to explore and understand, that a person shaking head or nodding head doesn't mean that they understood. So they may sign for the sake of consent form, but did we really made them understand? So this is another ethical question raises. You told them, okay, but did they understand? So this is something which is a gray area to define. Access and equity. Stem cell therapies can be costly, raising concerns about equitable access to this treatment. Stem cell therapy can fix a trouble. Two people are affected now. One is a rich person, another is a poor person. Stem cell therapy is available out there, and rich person I am fixing it because he gives me money. And poor person I am not fixing. I am telling, okay, you don't have right to live because you don't have money. Because when a therapy is there, and if it is a life-saving therapy, it should be open for all. Money should not come into picture. But we all know, for any treatment, money is the concern, the factor which comes in picture. So one can ask a question. Research and stem cell research is meant for helping humanity, and you are not helping a poor man rather you are helping a rich man. So these are all the ethical angles. Scientific rigor and transparency. It is essential to ensure that stem cell therapies are based on sound scientific evidence. Sound means strong, not audible sound. Scientific evidence, and that clinical trials are conducted ethically and transparently. So this is another angle. There are, like, if those who follow hospital connections, affairs, such things have come in lots of movies also. Like, if a person is dead, declared brain dead, so is he genuinely brain dead, or just because his tissue is a very exciting tissue which helps a man in queue to receive an organ, they find that okay, this youngster's organ tissue is matching, and he could have recovered back, he was just in an unconscious state, and doctors immediately declared him brain dead and took his liver or heart or whatever organ required for a rich man. So these are all the things one has to consider whenever there is a scientific progress comes for helping humanity. Equitability or equal distribution, irrespective of the person's social status, is a tough thing to, although it's an ideal thing to follow, but it's a tough thing to follow, because often the rich gets the things done what they want. Let us give some example facts about natural stem cell therapy. We have discussed about it. Natural stem cell therapy, the natural replacement of damaged cells by stem cells occurs actively and often in adult tissues, especially rapidly dividing cells such as blood cells happen every day. Like your skin is peeling, your intestinal epithelium is peeling every now and then, those stem cells underneath is fixing them. And exciting case example is there in Boston, however, posts a kind of natural stem cell therapy provided to a mother by her fetus. How did it happen? Long after the fetus is born, not took a stem cell from the fetus and injected into her, because there is a profound lack of medical intervention. This therapy seems to be natural enough, and this unlikely to be a moral suspect. But let us dissect out how did it go. Nevertheless, one may feel morally uncertain considering giving of this type of therapy to patients who would not naturally receive it. If a mother had an issue, organ failure, she got the chance of stem cell therapy because of the fetus in her womb. If she was not pregnant, if she was not had this fetus in her embryo, chances of getting stem cell into her bloodstream is minimal. So this asks a question: did one do justice to the fetus? But no one injected stem cell manually into the bloodstream. This is what angle you should think. Although one promising technology involves the blighted ovum utilization. So let us discuss a little bit more. Natural stem cell therapy, in a case, it's a case for moral evaluation. It ultimately demonstrates the importance of permissible stem cell research and therapy, and it is even absent in an agreement about the definition of when embryonic life begins. Is it start from egg? Is it start from sperm? Is it starting from zygote? Is it starting from blastula? So these are all questions which is not defined. Although one promising technology is blighted ovum utilization, uses fertilized but developmentally bankrupt eggs. That means it cannot give rise to an embryo. It is fertilized, but it will not give rise to an embryo. It is argued that utilizing unfertilized eggs to derive totipotent stem cells obviates the moral debate over when life begins in an embryo. How early an embryo is embryo? Is ovum an embryo? Is sperm an embryo? But one should also understand ovum and sperm are released, only one gets fertilized even in a natural breeding. How about the other sperms? How about other ovum? Not that one ovum is released, one ovum gets fertilized, and in a female's lifespan, throughout the lifespan, the ovums are getting wasted. Isn't it wastage of life there? So these are all some unclear areas. Two existing technologies fulfill this criterion. One is somatic cell nuclear transfer, which we discussed in the previous class, and parthenogenic stem cell derivation. If you made stem cell from a parthenogenic individual, it's a vegetative propagation. So we can technically call it is me only, my clone only, my extension. Something like that one can argue. And somatic cell nuclear transfer means I did not take the embryo. I just took a nucleus from one donor and put it into the ovum, and I made it to start dividing. So I created the embryo. But still one can ask, why not that embryo cannot make an independent life? It's almost like telling, if there is a monozygotic twins, two are there, one is afford, one we can kill, because normal birth only one is formed. So now two are independent are there, so one can be used for whatever you want. That logic doesn't help, because these are all the angles one should keep in mind. Although these technologies are far from therapeutic, yet concerns over the morality of embryonic stem cell derivation should not hinder their advancement. Means whether you use or not, you cannot say that it should not be there. It's just like, some governments, they acquire lots of weapons and lots of strategic weapons, but they have no plan of attacking any country. So if you have no plan of attacking any country, so cannot have? So this is the debatable question. One can ask, then why you need a weapon? You have no plan of attacking. Then another argument says, no, we want to safeguard ourselves. Then the question asked is, if you want to safeguard yourself, if you have no plan of using it, how it gave a protection? So the idea is, if you have weapons, it automatically secure you. Not use is your policy. So these are all the angles that when you make an embryo, whether you allow them to become independent or you allow them to divide certain stage and then you use it. So these are all the questions one should have. Let us go into detail about a case study. A 37-year-old mother of three kids comes into the clinic presenting abdominal pain, marked tiredness and puffy ankles. The standard array of diagnostic tests suggest acute liver failure. Your patient rejects all treatment options, including radical liver transplantation surgery. Patient don't want, and decides to wait and see how her disease stage progresses. Now comes the interesting part. Remarkably, perhaps miraculously, 6 months later, she shows signs of a complete recovery of this liver problem, which according to doctors needed a surgical intervention or a transplantation, despite a lack of medical intervention. That is what is to be. No medical intervention, it recovered. Just over a year ago, researchers at the New England Medical Center, Boston, presented new data on this scenario on an old cell type, pregnancy-associated progenitor cells, known as PAPC, pregnancy-associated progenitor cells, which might explain the patient's Deus ex machina recovery. What does it mean is, miraculous recovery is called, it's a Latin word, recovery. As far back in 1979, people used to believe, it was shown that women who gave birth to sons retain some of the son's fetal cells, for example, PAPCs, which can in turn give rise to multiple cell types along the hematopoietic stem cell pathway to differentiation. But actually, it need not be son, it can be daughters also. It has to be a fetus. After all, the reasoning goes that the placental blood barrier is not a perfectly selective portal, and some fetal blood and cells will cross into the maternal circulation. And since it is 50% mother, the tissue rejections will be minimal. And if it is rejected, it will not stay back. But if it is tissue matching is perfect, the fetus derived stem cells will circulate in mother. How long? Up to 27 years. What is surprising, however, is ubiquity and persistence of these fetal stem cells. They can be found in maternal circulation up to 27 years after the baby is born. Until then, if the mother is facing some trouble, it can get. This doesn't mean that if a mother gave birth for next 27 years, they won't get liver complaint. It depends on how much stem cell leaked, how those stem cells continue to divide, how they were not rejected by her immune system, etc. These fetal stem cells were found to localize diseased organs and repopulate them. For example, in one woman with a thyroid adenoma, a biopsy revealed two populations of cells. Her germline cancerous thyroid cells were surrounded by healthy thyroid cells derived from her son's fetus. Son, right now she is not pregnant, but she saw her own damaged cancerous cell and it is surrounded by the fetus cells. Even more strikingly, one woman with liver disease had significant repopulation of her liver with healthy fetal derived hepatocytes, the first indication of a functional non-hematopoietic stem cell derived PAPC. Now you bring in your ethical angle. You took embryonic stem cells from your own fetus without his or her permission into your bloodstream. Is it ethically right? Mother should have been dead. So one can argue in this angle. Whatever the mechanism involved, the idea of fetal cells expressing non-hematopoietic markers is novel and may have important long-term health implications, in this case benefits, for the woman who has undergone pregnancy by providing her with a younger population of cells that may have different capabilities in this response to tissue injury. Just because mother conceived, now she is getting an added lease of life because her organs could have been damaged because of old age. Now she has a fresh stock of fetus derived stem cell. The fertilization itself may occur not in the body but in a test tube. All of you would have heard about test tube baby. It is estimated that currently in United States alone, around 400,000, that is 4 lakh, frozen embryos left over from in vitro fertilization treatments can be used as a source of embryonic stem cell. If this is true, one can happily make stem cells, tissue matching stem cell, because they are frozen and they are never going to be inoculated because those parents already used. They take multiple eggs, multiple sperm, fertilize and make multiple, and no one who goes for a child care or to have a artificially inseminated or artificially made child, they don't want 1 dozen child, they want 1 child or maybe 2 child. What about the rest of the eggs and sperm? They freeze and keep it, so they are still there. Are these fetal stem cells that have our patients liver embryonic or adult derived? Now when this kind of situation is there, is it yours or it's your liver belongs to you or your liver belongs to your fetus or your son or daughter what you gave birth to? Fetal stem cells that transfer across the placenta and remain in utero for decades have been identified as adult hematopoietic stem cell. Because the hematopoietic stem cells cannot typically transdifferentiate into epithelial cells such as hepatocytes, the circulating stem cells in our patient are likely to be an embryonic origin, because of which they are able to give rise to the damaged tissue or the differentiation was possible, because hematopoietic stem cell normally doesn't do it that. What seems more important then is the potential moral objection to harvesting embryo for stem cell research and therapy. It is less contentious to harvest embryos, often dozens at a time, for assisted reproduction, which is normally done. The sheer number of leftover embryos in thousands of fertilization clinics across United States, one example country, because that country has got all the records of this, other countries also will have, is a testament to the moral acceptability of the technology. What is the fate of this 400,000 frozen embryos? Are they going to become humans? Are they going to be discarded? What is the purpose of keeping them? A few more ethical considerations. Those who have no moral qualms against such assisted reproduction technology may nevertheless oppose using these frozen embryos to derive embryonic stem cells for research purposes. One can always say, one husband, one wife, they are not having normal fertilization is not possible, they are not having kids. But doctors will intervene, they will take the egg from the mother, sperm from the father, fertilize and they implant into mother or a surrogate mother. It is perfectly fine. But that is allowed. You won't say that, okay, it is your fate, you shouldn't have kids, but that is assisted. But using that spare eggs, spare sperm, ethical question comes into picture. One distinction of these opponents make is that seeming unnaturalness of stem cell research. They argue that the only natural way to give moral weight to the lives of frozen embryos is to implant them and carry the fetus through a full pregnancy, which normally no one will do it. In vitro fertilization, it is argued, is merely assistance of reproduction, a natural phenomenon in which all healthy humans may engage. Usually, implanting a fertilized embryo back into mother's womb is analogous to using a respirator in assisting breathing or implanting a pacemaker to control the cardiac arrhythmia in a patient. Using fertilized embryo for scientific research disregards the natural order of things, disrespecting the sanctity of the embryo itself. So these are all the points to consider. The argument of such naturalness, the so-called in quote, is an old one. Forces larger than human beings shape the external world, a higher order with which we are not to meddle with. However, using naturalness as a proxy for morality fails when we consider other highly accepted medical procedures. There are many examples are there, including cancer treatment, radiation therapy, etc. Very basically, perhaps we keep a patient in life support despite his natural tendency to die. We don't let them die. So, because our morality support, but our morality doesn't allow taking embryonic stem cell and putting through these frozen embryos. The pacemaker we install creates an artificial, not natural rhythm in the heart. We induce childbirth sometimes as early as 32 weeks if the mother's life is in danger. If we feel that the baby's health would suffer or mother's health would suffer during a prolonged pregnancy. Indeed, in vitro fertilization itself is hardly natural in that it eliminates the conception from reproduction process, natural reproduction process. It seems that all advances in medical technology to do something unnatural to alleviate pain and suffering or to offer the joys of various natural procedures like childbearing intent to further natural life seems a more appropriate standard than naturalness. So these are all tough area to dissect out. Moreover, regaining the ability to walk after suffering from a spinal cord injury or seeing light after several years of retinal degeneration potentiates the benefits of stem cell therapy. Surely weigh the same on a scale of naturalness, a childbearing to which these critics do not seem to object. So, failure to signal the mother that the development in progressing within normal limits results in spontaneous maternal reversion to non-pregnant state with the expulsion of failed conceptus. Such mechanisms to ensure the robustness of offspring are probably as important to the species survival as the capacity for reproduction itself. Nature celebrates success and disdains failure. This is what we always see. An inability to develop into a healthy offspring does not, however, necessarily negate the potential of fertilized egg to give rise to stem cell. That should be allowed. Thus, many eggs traditionally doomed to die during embryogenesis could be utilized for stem cell production. So this notion highlights the urgent need to be able to distinguish developmentally capable fertilized eggs from unacceptable fertilized eggs. So every oak tree was once an acorn. It does not follow that acorns are oak trees or that I should treat the loss of an acorn eaten by a squirrel in my front yard as some kind of loss as the death of the oak tree felled by a storm. Despite their developmental continuity, acorns and oak trees are different. So are human embryos and human beings. So we will learn more about the embryonic stem cell and regeneration biology in the next class. Thank you.